Okay, this is the 310 to 311 review. Calculators are not allowed, and this is a free response. So there's quite a bit of work involved with this one, and I will kind of tell you that you might want to set it up and read the whole thing first before you continue on. So here we've got an equation, y equals 1 over x squared. We've got some coordinates, p, that are v comma 1 over v squared. And then we've got this q, whose coordinates are v, 0. Notice that the x coordinate of p and q is the same. And then we have r over here, whose coordinates are u comma 0. And what we notice about r is that it is the x-intercept of the line L, which is the tangent to the curve, which is the line tangent to the curve at p. So our first job is to find u in terms of v. So that means we've got to somehow connect u to v, and the thing that they have in common is this line at p, which involves v. So we need to write the equation of the line and then find its x-coordinates. So that's how part A is going to work. When we do that, we'll have a relationship between u and v. So that will help us in part B, which is we can plug in v is 7 and figure out what u is. Then if we look at part C, we've got information about dv dt, because v is increasing at a constant rate, and we want to know what is du dt going to be. So since in part A we're finding the relationship between u and v, part C is just going to involve taking the derivative of that relationship and then plugging stuff in. Then the final part, which is also pretty tricky, is we have information about dv dt again, and an instant in time, and we're interested in the area of the triangle. So that means we're now going to have to relate the area of the triangle to dv dt, and then interpret our results at that instant. So parts A, B, and C we do without the triangle. Part D, we're going to utilize the area of this triangle here. So let's start first with finding u in terms of v. The connecting piece is that tangent line. In order to write an equation of a tangent line, we need a point and we need a slope. Now remember that the slope is the derivative evaluated at the point of tangency. So I'm going to come up here and rewrite y as x to the negative 2, which means when I take the derivative, I will get a negative 2x to the negative 3, or negative 2 over x cubed. So when I evaluate the slope at the point, it will be a negative 2 over a v cubed. So be very careful here. If you do not compute the slope at the point, then I'm going to dock you points and stop grading, because everything else will be a wreck. So don't make that mistake or you'll miss a lot of points. Once we've got the slope and we've got the point, we can write the equation of the line. And once we have the equation of the line, we can find the x-intercept. So the x-intercept of that line is the point u comma 0. So that means if I plug the point u comma 0 into the line, it should make a true statement. So looking at this right now, we have an equation that involves u and v, which is great. But if we want to make sure we do what they ask us, we want to get u in terms of v. So that's telling us to isolate the u. Now looking at this, I see a lot of errors algebraically trying to isolate u. The simplest way to deal with this is to multiply the entire equation by v cubed. And we know we can do that because v is on this curve and 0 can never be plugged in. So we can multiply both sides of this equation by v cubed. When we do that, we will get 0 equals a negative 2 times u minus v plus a v, because the v cubes will cancel when I multiply this term by a v cubed, and then here the v cubed will be on top and a v squared will be on the bottom. We can reduce it to get a v. Now that we're here, we can distribute that negative 2 through. We can combine our like terms and pull the 2u to the other side. Oops, that's a v, not a 3. And then we can divide by 2. So we have now found a relationship between u and v. So the point breakdown for this particular section is 1 point for taking the derivative of y and then evaluating that derivative at v. That's 1 point. Your next point comes from writing the equation of the line, and your final point comes from determining that u equals 3/2 v. So now that we have that relationship, we are ready to continue on. Part B says I want to figure out what u is when v is 7. Well, I just plug in 7 and I'll get u equals 3/2 times 7, which is 21/2. Part C says, okay, now we've got v increasing at a constant rate, and I want to know what's the rate of change of u with respect to time. So that means I will take this relationship between u and v and differentiate it with respect to time. When I do that, I'll have the relationship between the rates. So that will give me du dt equals 3/2 dv dt. Now I told you that dv dt is a positive 2. So that means du dt at that moment will be 3/2 times 2, which is 3. Now because this is a free response, we need to interpret what that means and apply the units. So since v is increasing at units per second and u is just another single point coordinate, it will have the same units. So we'll get 3 units per second. And the interpretation would be that v is increasing, or not v, excuse me, u is increasing at a rate of 3 units per second. So breakdown on points for B, you get 1 point for the answer. Breakdown on points for C, you again get 1 point for the answer, and you have to use dv dt is equal to 2 in order to get there.